Welcome to the CBE 3 review. My name's Aiden. I'm a recitation leader for Comp 1 with Xavier Parent. Those two are in my class, but I'm assuming you guys aren't. Anyways, welcome.
My name is Laurel. I'm a Staff 3000 recitation leader. I'm just helping out. This is going to be recorded, so they will hear your voices if you ask questions, but we won't say your names, so we'll remain anonymous. But yeah, feel free to just if we're doing something and if we do it wrong, please just call us out because we don't want to go through the whole problem wrong. So.
Yeah, we're not perfect, and then if you have any questions or you need to stop us, this is your guys' review as much as it is ours, right? So you guys are here right now, so feel free to stop us and ask questions whenever you have it, and we'll be going over all the topics for CB3. So.
Okay, cool. Sorry, it just timed out. And can you guys see that, or do you want us to go into present mode?
That's fine. Are you going to present mode?
I think it's.
Is it that one?
Yeah.
Oh, wow.
And then if you want to get to your pen, it's right there.
Okay, cool. So the CBE is going to be covering, I'm sure your teachers have already said this, hopefully, just lessons 7 through 10. So you got the derivative of the trig functions and the arc trig functions, the chain rule, implicit differentiation, and then logarithms and logarithmic differentiation as well. So, derivative of trig functions. I'm going to go over here.
Can I see the pen?
Yeah. Alright. Hopefully you guys have all seen these before. Yeah? Easiest one, sine is cosine. This one actually always trips me up. Cosine, the derivative of cosine is negative sine. And the derivative of tangent is secant squared. And then you have all of your inverse trigs as well. There's a nice trick that actually helps you memorizing this as part of the unit circle. So if you start at the 90 degrees, if you just start right here and then you go 90, that becomes the derivative of that trig function. So then if you start at the cosine and you go, what is that, clockwise?
Yeah.
If you go clockwise, it's negative sine. The derivative of negative sine is cosine, negative cosine, and the derivative of negative cosine is sine. It's super helpful. And other than that trick, I don't really know.
I know one.
You guys gotta kind of just memorize it, in my opinion. But these ones aren't as needed after this CBE. So, yeah.
I know one for secant and tangent. So you make a triangle. Doesn't matter where they're at, just as long as two of the points are secants and one is tangent. And if you take the derivative of one, it is the two other sides multiplied together. So the derivative of secant is going to be tangent times secant, and the derivative of tangent is going to be secant times secant.
Oh, that's a good trick.
Those are little tricks I do with, especially with this guy for sine and cosine. Can be really nice. I do this. I don't have these memorized, but I probably should. But if you just go in on your test or CBE or whatever you're taking, and you just write down a little axes, like coordinate system in the corner, and you just label that really fast, then you can just, you don't have to think about it. You can just reference it. You know, just a lot of less thoughts you have to think about. But yeah.
Yep. Yeah. Any questions about the trig rules? No. Inverse trig rules. These ones are a lot harder. Do you have any tricks of memorizing them? We talked about this in class today, but I just memorized them.
I mean, you can.
Welcome.
Well, not really.
Yeah, I don't really know if there is tricks. The best thing I can give you guys is basically the sine and cosine ones are the same, but cosine is negative. That's all you gotta remember.
Wait.
And then
should that be? Oh, never mind. Sorry. Yep. Great.
And then the tangent. I was talking with my other recitation there. This is the one that's pretty. So this is the most workable of the arc ones, arc trig functions. And so that's how I kind of remember. It's just 1 over 1 plus x squared. But you'll see they're all a combination of 1 and then 1 and x squared. So I think that kind of help you. And then I don't even know if you guys have really used these ones, the inverse arc trig functions, but definitely memorize the sine and the tangent arc trig functions, and then The cosine one isn't too far away from the sine one. If you remember, they're the same and point of one's negative. So hopefully that'll help you a little bit, but I don't really have any other tricks. You just gotta kind of remember those. Maybe do like a brain dump right before you go in. Just like cram it, then write it down on scratch paper when you get into the testing center. That's what I would do.
I have tricks for trig integrals, but not derivatives. It's not helpful though.
Yeah.
Okay, so for problem 1, it wants us to find the derivative of this function and then evaluate it at 0. So when you guys first look at this, what are our 2 derivative rules? Like, if I say product rule, then what's the other one?
Quotient.
Yeah, we're going question rule.
Perfect. So, pretty sure I spelled that right. Okay, so what would you think this guy would be?
Question rule.
Yeah, and which one's easier? Product rule or quotient rule?
General
Product
rule, right?
Yeah, so let's try to make this product rule. So we have f of x equals that 2 arctan of x over cosine. But that's the same thing. What's 1 over cosine? Yeah, so we can just pop a secant in there because it's the same thing. Now it is a product rule. Excellent, right? Okay, so what was our derivative of arctan? I'll give you a second while I write this down. Maybe let's go back for a second. Yeah, 1 over 1 plus x squared. Perfect. And then what's our derivative of secant? So it'd be the 2 other quarters.
Secant should be secant tangent.
Yep, perfect. Okay, great. So then we'll just pop these guys back together. We have our f prime of x. So we do derivative of the first. So that 2 will be there. That'll be secant x. 1 plus x squared. And it's plus the second times, or sorry, the first times the derivative of the second. But you can flip those, right? Because it's addition, so it's, yeah. Okay, cool. So we'd have that secant x tangent x, and it'll be times our 2 arctan of x. Okay, cool. All right, and then we gotta pop 0 in there. Normally, if you have to evaluate, I don't recommend simplifying because, I mean, do you? It's
No.
yeah.
It simplifies itself when you just plug it in. So when you see something like 0, you know a lot's probably gonna go away. And so I would just plug it in.
Yeah. So what is secant of 0? Do we know that? Okay. Yeah. So what's cosine of 0?
One.
Did he just tell you? You little cheater. Okay. So.
I didn't say any question.
So this will be 1 over 1, which is just 1. So then this chunk will be 1. So we'll have 2 times 1 over 1 plus 0. Plus, okay, so we know this is 1. And then we have our 2 here. And then what's tangent of 0? Well, tangent is sine over cosine. Yeah, 0, because sine of 0.
Sine is the y, right?
Yeah. So then we'll have, well, if this guy's 0, then let's not worry about what this is, because it's just going to, this 0 is just going to drag everything down. So it'll just be plus 0, which is equal to 2. Okay.
Any questions?
Okay. All right, so we have the chain rule next. It's kind of our little derivative helpfulness. So this is when you have functions that are nested inside of each other. So you can see this outer function here is f of x, and then this inner function is g of x. So when we do the chain rule, we take the derivative of the f of x, and then we keep the g of the x the same, and then we multiply that times the derivative of this inside. So there's like 2 parts. So it's like a nesting doll. It's like you look at the outside one, pop off the top, take out the little one, pop off the top. I don't know if that helps you guys, but that's how I think about it.
Yeah, I guess an easy way to remember it is you have an outside function and an inside function. So like you have like cosine of x squared, then you'll take the derivative of your outside function first, and then you keep the inside function the same, and then you multiply by the derivative of the inside function. So kind of like she was saying, like the nesting doll, you take the outside first, and then you take the inside, and you just multiply together. I think the part you get messed up on the most is you either forget to multiply by that derivative, or people will change the inside function too early. So just make sure you keep g of x when you plug it back into f prime, and then you multiply by g prime of x on the outside. Yeah.
Cool. Any problem too?
Yeah. Alright, so this problem's not very pretty, but we can do it. So first, what rules are we gonna need to do this problem?
Product.
Yeah, so we're gonna need the product rule and the chain rule. And so when I'm looking at the chain rule, what's gonna be like, what part is the chain rule? Where am I going to apply the chain rule?
So the outside function would be the -3 tangent. This one, then the inside would be the 2e.
Exactly. So I'm going to label this as f. And I would recommend you do this on your test. This is going to be f of x, and this is going to be my g of x. Yeah. That way I can keep the kind of like the inside and outside function pretty straightforward. I always label my two functions with any of the rules: product, quotient, chain. So, okay. So now when I take the derivative of the outside function, so that's going to be -3 times the derivative of arctangent, which is, if you guys remember, 1 over 1 plus x squared, right? But then this x squared, how do I erase? Do you know how to erase?
I think you have to go click on the pen. Or no, this guy. And then you go eraser and that guy.
Thank you.
Yeah, it can kind of be, I would do it with your finger. When you try to tap with a pen on the changing the settings, it doesn't work for some reason.
Really? Okay.
It's sticky.
I wonder if you can like scribble it out.
Do you guys have iPads?
No.
Dang, it doesn't work.
So,
Which app are you using?
it's just PowerPoint presentation.
Oh, that's a weird one.
Maybe try holding the pen down on the.
Wait, how do you do it again?
So you click on the pencil, so it's like settings.
Oh, I
and
clicked
then-
on the wrong
And then
pencil.
you're trying to go to, or sorry, what? Okay.
Yeah. Okay.
Yeah.
Sorry. Okay. So it's gonna be x squared, but
Just don't mess up and then you don't have to switch it.
yeah, I was trying to prove a point, but then it backfired on me. So then x is going to be our g of x, right? Because we're taking the f of g of x. So we're gonna say this whole thing is squared, okay, times my derivative of g of x, which is going to be another instance of the chain rule. So I'm going to bracket it off just because I really like to separate all of my terms. It's going to be 2 times the derivative of e to the x, so e to the 4x. And I have to take the derivative of the 4x because it's the chain rule again. So it'd be times 4. Yeah, times 4. So then this equates to -24 e to the 4x over 1 plus 4e to the 8x. I didn't show a lot of the steps, so please, any questions? I might write it a little better.
So
Yeah.
that section there where it says 2 times e to the 4x times 4. I've seen people do this multiple times, but is it just like the product rule, or not the product, the power rule, but you don't subtract anything from the power And is that ever not the case? Because I've seen it, usually it's
So-
just 4 times 2. But I don't know if that's.
What happened here is, so the power rule doesn't apply to e to the x.
Right, I know it's not the power rule, but it's very similar. Is it the same pattern always? Or does it change?
It's like chain rule again.
Yeah.
So it's like you imagine that your e to the x is one function,
Yeah.
then it's e to the 4x. So then you have to,
Got it.
yes. So it's just like another nest.
Right.
Is that helpful?
Yeah.
Exactly, like our e to the x is the outside function and the 4x is the inside function.
So there's actually like 3 chain rules here, or 3.
Yeah, exactly.
Yeah.
Yep, and so then this is our f prime. I do not like this pencil.
Isn't it hard?
It like jumped.
I know. I put my sleeve. I think it's because you're scanning. I put my sleeve up so you can run on that.
Okay, I'm gonna have to try that. So yeah, cool. Any other questions? Awesome. I think we got problem 3.
I know it is annoying. I agree. Okay. So for this guy, it wants us to find the derivative again and then evaluate it at 0. So, okay, what is our big function? Because we have a couple things nested here. What is this? What is our outside guy?
Square root, well, not square root,
Yeah,
4th root, whatever
Yeah.
it is.
I don't quad root.
Maybe, yeah.
Are you guys cool if I write it to the 1/4? Okay, cool. And then what is our inner guy?
X to the 5th plus 2x.
Mm-hmm.
X to the x.
X to the 5th plus 2x plus e to the x. Perfect. Okay, and what's the derivative of h?
1/4 x to the negative 5/4. Is that right?
Ugh, I have to think about that. So it'd be 1/4 minus 4/4. So negative 3/4.
That's right.
And then what's our derivative of g of x?
5x to the 4th plus 2 plus the x.
I'm like stalling. Thank you. I'm stalling because I want to actually make sure you guys know how to do this stuff. Okay, cool. So now what we're going to do is we're going to go back here, f prime of x. So it's going to be the derivative of our outside guy. So is this guy. So it'll be with our inside stuff still intact. And then this will all be to the negative 3/4 over 4. And then we'll multiply that by the derivative of the inside, so this guy. So it'll be times 5x to the 4th plus 2 plus e to the x. Okay, cool. Are we done?
Probably simplify.
Maybe, but if we are going to plug it in, I don't like simplifying. It's a bad habit.
It'll just save you time if you don't simplify.
Yeah. Normally, yes, you're correct. Okay, so then this would be 0 plus 0 plus, what's e to the 0?
I think it's 1.
Yeah, what's anything to the 0?
1.
Excellent. Okay, negative 3/4, and then this is all going to be over 4. It's going to be times 0 plus 2 plus 1. Okay, and then if this is all just going to be 1, so what's 1 to the anything?
So
Yeah, just be 1/4 times 3. 3/4.
Nice.
Is that what I got? Oh, it is. Let's go. Okay, cool. Do you guys have any questions on that?
What are all the rules being used here? So there's
Yeah.
power rules being thrown in.
Yeah, so we're doing
I'm just kidding.
the chain rule, right? Because we have these our h of x and our g of x, where our h of x is this outside guy, and then the g of x is this little guy in there. Ooh, that's itty. Okay, and then I think that's it. Is it just chain rule?
Yeah.
Yeah, okay.
Same.
Because this guy's just e to the x, so we don't have to do product rule on him. Well, I guess, or chain rule. I guess you could be doing a chain rule on him, but the derivative of x is just 1.
Technically, everything's a chain
That's
rule.
true. That's deep.
Right, right.
Do you guys have any other questions?
So yeah, and it's probably got the chain rule and the power rule and the EPF rule.
There, I wrote it down. So now if you look at slides, you can see we did it. Okay.
Yeah.
24.
All right. Catch my mistake if I don't know if I don't rationalize correctly.
I'm just gonna take it.
Okay, this one is honestly just a chain rule. So I'm gonna write it like she wrote it. So I'm gonna have my outside function. Did you put g of x as your outside or h of
I
x?
did h of x, but
Okay.
it's whatever.
I just want to keep it consistent. H of x is going to equal 2 sine of x, yeah? And my g of x is going to be 3x squared minus 2. Okay, so then we're going to take the derivative of the outside, plug in the inside, then multiply by the derivative of the outside, of the inside. So it's going to be 2 times, what's the derivative of sine? Positive or negative?
Positive.
Positive cosine. I'm going to plug my inside back in. Times, and then what's my derivative of g prime? Or,
6x.
yeah, 6x. Which is going to give me 12x cosine of 3x squared minus 2 equals f prime of x. Okay, so now it's asking me I have to find f prime of that point, right? So I have to plug in. So then f prime of square root of 1/2 is going to equal 12 times root 1/2 times cosine of 3 root 1/2 squared minus 2, which ends up being you rationalize, isn't it 6?
What are you doing?
I'm
Just
trying
rationalizing
to,
the
yeah.
1 over root 2.
Uh-huh.
So it'd be, 6 root 2.
Okay,
Did you do that right?
I think that's right.
We could write it out. I don't rationalize mine, I'm gonna be honest. But yeah, because you'd have a 2 on the bottom, and then
I know it has 6 in the answer. All right, 6 times. Oh, wait.
yeah, 6 root 2.
Yeah. Thank you. We have the cosine of, so then when root 1/2 is squared, the root goes away. So you just have 3 times 1/2. 3/2 minus 2 is negative 1/2. And that's as simple as we can get it without a calculator. So that should be the answer. Any other questions? Or any questions?
So is this the answer we're gonna put? We're not gonna rationalize it further than that?
I think if you kept it like this and you simplified the inside to right here. Oh, you guys can't see where I'm pointing. If you kept it like this and then you put cosine as negative 1/2, I think that'd be fine on your CBE. I don't think most teachers don't expect you to rationalize, right? Yeah. So,
For a test, can we just plug it all into the calculator and whatever number it gives us, that decimal number?
don't do CVs.
Well, I don't think our calculator's gonna have square roots.
Yeah, it's just
This is not.
condition.
Oh.
I would just put it in like that, honestly. Give it the exact answer.
I don't think I've ever had anything
Cool.
like that, some arbitrary ones.
Alrighty. Okay, we just have to find the derivative. This one shouldn't be too bad. Okay, what are we looking at here? Do we think chain rule or some other beast of derivativeness?
Sounds good to me.
Okay, what's our outer function?
1/3 time. So negative 1/3.
Yeah, arc sine. And then g of x is what?
2x.
It's pretty chill. Okay, I get the easy one. Okay, so then what's our, do we remember the derivative of arcsine?
Do.
1 over square root.
1 minus x squared.
And it was positive because cosine was negative. I can't believe I remember that. Okay, and then this 3 is going to be hanging along. And then g of x prime, just 2. Okay, cool. So we're going to have f prime x is going to be equal to our derivative of our outside. So 1 over 3. 1 minus x squared. But then this is just going to be a 2. Dang it, I did what you did. Ah, okay.
It's nice for teaching the chain rule to like plug it back into 2, but then it's mathematically proper, you can't rewrite it like that.
I know, it's awful. Okay, so this would be 2 squared. Oh, wait. Oh my gosh, no, I did it wrong. Wait, do you guys see what I did wrong there?
No, see it, not looking.
Okay, I plugged in g prime of x.
Should be 2x.
Yeah, because we're not plugging in our derivative of g of x. See, that was a teaching moment. I did it on purpose. It was a test. Oh my god, this pen. Okay.
We walk so you guys can run.
Wow, that's deep. Okay.
Amen.
So now we multiply by that too. Okay. That was a little painful. Let me rewrite this so it looks pretty. Well, okay, the pen is so squiggly. 4x squared. Is that correct? Okay, it looks like that's what they have. Do you have any questions? Yeah.
Would it work to I don't know why you would do this, but would you be able to rewrite the function with like the 1/3 across the whole thing so it's all over 3 and then you do the quotient rule?
So since it's a coefficient, so you're saying could we do this and say
Yeah.
this is our f of x and this is our g of x?
Yeah.
So it'd kind of be a little like redundant because it's a coefficient. So just go to 0. So it would take
Yeah.
that entire because it
Okay. Yeah. But would you still get like the same answer?
Yeah, it technically would work. I've done it before, but
Yeah. I don't know why you would do that, but
because if you took g prime of x right here, that would just be 0. So then it'd just end up being this, which is basically so
okay.
it really wouldn't.
No, you're right.
Okay, that was a good question though.
it's
Okay,
a good test taking strategy too, actually. Like, if you forget tricks, you can always trust your derivative rules. Like, the product rule and the quotient rule will always work. They might be more work, but they will always work. Or the chain rule will always be true. So if you guys ever get stuck, you can always just go to that, and then you'll get 0 and it'll cancel a bunch of terms. But
and try to get things. Well, I try to get things into the product rule if I can, just because, like, remembering. Do they get formula sheets?
no.
Okay, remembering this over remembering that is a lot easier for my brain. I don't know about you guys, but yeah. Okay. Yay.
Implicit differentiation. Who remembers implicit differentiation? It's been a little bit. That's on. Okay, cool. It's a little weird. I think it's one of the more complex concepts in Calc 1 to grasp. But once you get the hang of it, it's really not too bad because usually the problems are easier. Like the derivatives are easier. So first you're going to assume that y is a variable. And so you think about it as like y and y prime. I like to tell my students like y is actually a hidden function of yx. We just don't know what the x is. And so then you're going to take the derivative of both sides because you have your equation. So it's like when you multiply your equation on one side, you have to multiply it on the other side. Same thing with derivatives. You have to take the derivative of both sides. So like, if let's say like this was x squared. If y equaled x squared, you're technically still taking the derivative of that y side to get y prime. And then you'll get 2x as your derivative, right? And so that's helpful for me at least to kind of remember the process. Then once you have your derivatives, you're gonna solve for y prime. And so one thing I actually forgot to mention in the step before is as you're taking the derivative, every term that has a y derivative gets tagged with a y prime at the end. And that's because we don't know what that extra part of y is. Like if y was yx or y of x, it's essentially applying the chain rule and you're multiplying by the derivative of the inside, which is y prime. It's a little complex. If you're worried about the test, just remember every time you take the derivative of a y, it's that derivative times y prime. Okay? We'll do some practice problems, so it'll work itself out. Then you'll solve for y prime. Most of the time you'll have like terms like this. You'll have to factor the y prime out, so it'll be like y prime times parentheses a term, and you can just divide that, and you'll get y prime equals, and it's usually a fraction. So. Yeah.
Cool. And y is not a constant, so don't try to yoink it and make it 0. It would.
Yep.
That's not good.
Cool.
Yeah, I know. Okay. Yeah.
Alright, let me see if I remember these. So here we have our function, and so first I'm gonna take the derivative of both sides, which is going to give me, wait, I want to erase that. I'm gonna write it better.
Get right over it.
Can I? Yeah, so I just take, oh, my pencil's gonna die, it has 20%.
What?
So I'm taking the derivative, that's what that means. And so then it's going to equal, so I first have to take the derivative of this first term, which you can immediately recognize as the quotient rule, or you could do a variation of the product rule. Since we already did that, I'll do the quotient rule, because that's just
Which
how I
one
do
would
it
be
anyways.
easier?
Depends on your preference. I think the quotient rule is just as easy, personally.
Really?
Yeah.
It's cool. There's a lot to remember, though.
Right. I understand why it's more difficult to remember, but I'm an engineer, so I just like my formulas, personally.
I'm not an engineer.
So, anyways, we're going to take the derivative of the top, which is 1, oh my gosh. Sorry, 1 times dy dx, because I take the derivative of y, minus the derivative of the oh wait, times x. Sorry, guys.
I wonder if you put a tissue under your hand and then it wouldn't respond to it.
Oh, maybe like one of those gloves that people wear. Okay, so that's the derivative of the first term of the quotient rule. Then I'm going to take the derivative of the bottom, which is also 1 times y over x squared. And then the rest is, in my favorite word, trivial. So you get 2 plus 5 dy dx. Yeah. So then I'm going, and that's equal to, somehow I ran out of space, equal to 0. Should I write it on the bottom? Yeah, so then I'm going to multiply. No, I'm not going to do that just yet. Okay. We're going to do it this way. So then I'm going to try to get rid of the x squared on the bottom. And so actually in this case, I bet the product rule would be easier. I'm just going to put that out there. Dx times x minus y is equal to 2 plus, actually minus, is that the eraser? Minus, I'm in black, okay. 5 dy dx times x squared. Yeah. Wait.
I can look at my thing.
I did it this way on my homework. Okay. Problem 6, yeah.
I I did each part individually and then I recombined it. Where are you getting stuck?
I don't know how to get the. For some reason, I'm like lost right now. I can't get rid of the dy dx time. Oh yeah, cause you can just multiply. Yeah, yeah.
You do it
Okay.
last.
You can also do that. This is what I'm gonna do actually. So then this is just going to be 2x squared minus 5x squared dy dx. And so then we'll get the whole equation. If I move the y primes of the dy dx's to one side and the other terms to the other side, you'll get negative y minus 2x squared is equal to negative 5x squared dy dx minus x dy dx. So then if I factor this out, I can say, gosh, I'm gonna run out of space. I can say this is also equal to negative 5 x squared minus x dy dx. I'm super out of space.
Do right in between the lines. Just do arrows. Don't do this on your work guide. You better than that.
Wait.
You'll have more space though.
Can I move it? On my iPad, you can move it. Okay.
Yeah, I guess not.
But essentially, so then you're going to divide by this term right here. And you'll get dy dx equals. And since all the terms are negative, you can also just make it positive. I'm just going to write it because it'll be easier to read. Plus 2x squared over 5x squared plus x. Sorry, I got a little cramped right there. I feel kind of bad. I'm usually more organized with my work, but
It's okay.
there we go.
It's not much space.
Yeah. Any questions? We do have another one of implicit differentiation, I'm pretty sure.
I think so.
Yeah, with the tangent line. Cool.
So I do have a question. The 5y.
Yeah.
So when you derive that, the y goes away.
The 5y
You add 5y. When you derive that,
right here.
yeah. I thought the y stayed, and then you also have dy over dx.
So because I'm taking the derivative of 5y, it's like saying taking the derivative of 5x.
Okay.
That's just 5, right?
Mhm.
Because of the power rule.
Okay.
So I take the derivative of 5y, it's just going to be 5 times y prime. Which
Got
is
it.
5
Which is dy over dx.
Yeah.
Got it.
I should have written it y prime, that's my bad. That's just how my teacher always writes, I guess.
The dy dx.
Yeah, but it's way cleaner if you write y prime.
Yeah, that's fair. Have you taken ODEs?
Yeah.
Okay. Do you guys have any other questions? Okay, go on to the next one. Alrighty, so for this one, we have to find the slope of the tangent line at that point for the following equation. Okay, so we're gonna take this one step at a time. I'm gonna derive each part of this. So let's just do 6 sine y first. Okay, so what is this derivative gonna be? Well, we'll have the derivative of the sine. So what's that guy? Yeah, cosine, because we go clockwise. So it'll be 6 cosine of y, and then we take the derivative of the inside, which is y, but this is in terms of x. So we just make it y prime. Cool. And then we have our next chunk, which is this guy. So it's going to be d dx 3 cosine x. Oh, we'll keep that negative. Okay, cool. So then what's our derivative of cosine x?
Negative sign.
Yeah, and then if it's negative sign, these negatives will cancel.
Sorry, it's 3 sines.
Yeah, so 3 sine x. You could have also just done negative sine, or sorry, whoops, negative cosine, and then, yeah, either one. Cool. Okay, and then what's the derivative of this guy?
0.
Yeah, that was not a trick, I promise. Okay, so now what we're gonna do is I'm just gonna put these back together. So it's gonna be 6 cosine y times y prime equals, oops, sorry, plus 3 sine x equals 0. Okay, what do you guys think we should do next?
Plug in.
Yeah. I expect
Minus the 3 sine to the other side,
Yeah,
and then divide by 6 cosine.
so move this guy over and then divide by this guy. So this will be 1, 2, so it'll be negative sine x over 2 cosine y. Okay, cool. Are we done?
now we plug in.
Yeah, now we plug in our point. So, oh, it's cheating. It says it right there. Okay, well, anyway. So we'll have negative, well, I should probably write it all nice. That's really small. Okay, so we're gonna have negative sine of x. What's our x in this case?
1/2.
You did that really fast. But yes, pi thirds, which this will go to 1/2. And then what is our y? It'll just be the pi 6. Do we feel okay looking at this and identifying our x and our y? Kind of. Okay. All right, so then that top is just gonna go, wait. Is it 1/2?
Yeah. 1/2.
This one is?
Yeah.
Wait. Uh-oh, I think I did my unit circle wrong then. Pi thirds is right here. This is pi 6th and pi 4th. So then, wouldn't that be root 3, root 2?
Yeah, root 3 over 2
Or yeah.
for both of them.
Yeah, okay. No, you're good. I believed you, man. I was going along with it. Okay. Okay, we'll write it down here because we're out of space. So this will be negative root 3 over 2 over, and then this one is pi 6, which is that root 3 over 2 for cosine. So it'll be 2 root 3 over 2. Doink, doink. Those 2's are going to cancel. So we'll have negative root 3 over 2 times 1 over root 3. Look at that. Isn't that nice? That's a well thought out problem. So we're left with negative 1/2. Okay, what does that mean in context of our problem?
The slope of the tangent line.
Yeah.
So that's the.
Yeah, so if we were to graph this guy and then we were to look at the slope at that spot, then it would be negative 1/2. Which isn't like super fast, but it tries.
Somewhat fast, though.
Yeah, that's fair. Okay. Do you have any questions about any of this? Okay. It's like a battleground every time we write.
Literally. Remember, derivatives are the slopes of lines of your function. So anytime it asks you for a line and you need to find the slope of that tangent line, you're going to need the derivative of your function and a point. Those are the 2 requisites. So, yeah. Alright, cool. Who here is confident in logs and logarithms? Anybody? Okay.
I feel you.
Most mathematicians aren't, if that gives you any confidence. So, luckily in calculus, it's simple enough. So, yeah. First, we have our exponential rules of derivatives. So we've already done the e to the x a couple of times here. This is just the chain rule. So the derivative of e to the x is always just going to be e to the x. And if this happens to be another function, then you multiply by the derivative of that function. Okay. Then this one's a little bit more unique, I guess. So we have a, which is just a number. So it could be 3, 5, whichever. A times a function of x. So you have the x and the exponent for this to work. Right here. And so then the derivative of that is going to be whatever you started with times the natural log, which is ln of your base number, which is going to be a, times the derivative of g of x. Okay? So it's kind of another chain rule. This is a to the x, so then derivative of a to the x is a to the x times the natural log of a. And then you have another derivative, you have to tack it on.
Did I do this right based on that? Or wait, that's wrong.
That would be 3.
Yeah.
Then, yeah.
Do you guys have any questions about those?
That's another one that you can memorize and then look up after you pass the class. So I'm just gonna keep it real.
That's fair.
we have our ln function, or the natural log. So wait, sorry, derivatives of logarithmic functions. Okay, our natural log. This has a whole proof. You just remember it's 1 over x. Okay, the absolute value also 1 over the x because the natural log cannot take in negative numbers. So they're the same thing. Then you have the log base, whatever. Basically, if it's not ln, and most of the time it will be ln, but sometimes it won't. If it's not ln, this is going to be your derivative. It's going to be the derivative of basically ln of x times, in the denominator, the natural log of your number right here. Okay? That's the key. It's the natural log of the base number, not of x, or not of a coefficient in front, of the base. Yeah? Cool.
It's like the power stick.
Yeah.
Is it actually almost done?
Okay. It has 15% life is on. It'll last. Alright. So logarithmic differentiation. It can look intimidating at first, but there's a lot of tricks you guys can use to simplify it. Right? So first I'm going to simplify this because I know that if I have a number on the inside of a log function and it's the quotient, basically if I have two numbers divided by each other, I can split that up with the log by saying the top minus the bottom. And that's just a log rule right there. Now it's a lot more easy or achievable to take the derivatives of these two terms. Okay, so then I'm going to say f prime of x is going to be, so my first term, because the derivative of ln of x is 1 over x, so it's going to be 1 over e to the 3x, because of the chain rule, times the derivative of my inside function, which is going to be e to the 3x times 3, right, chain rule, minus, I'm just going to bracket it off again, 1 over 2x plus 5 times 2. Squiggly line. Okay, which simplifies, we don't need to plug in a point, which simplifies to 3x's, they just cancel, right? These be 3 minus 2 over 2x plus 5. Yep, and you can simplify this more, and you'll end up getting like, I think it's 6x minus 13, no, plus 13. But I feel like that's also an acceptable answer.
So this person is intelligent because I, when I solved this problem, did the quotient rule, which was very ugly, but I did get that, but it was intense. So I'm really glad you did that problem.
Yeah. So the main reason why we'll get into a section here called logarithmic differentiation. The main reason that exists is because you can simplify functions like that and not have to do the quotient rule.
Be smarter than me, guys.
Yeah, well, I did the quotient rule on the other problem, and I definitely should have done the product rule. So
That's
to
fair.
each their own. But yeah. Any questions about how I got here? Okay, cool. Let's move on to the next one then.
Is this one easier again?
No.
Oh, what?
Can't simplify that one.
Okay. All right, we're gonna do this one chunk at a time. So, okay, what do we got going on here? Let's name our functions. What do we want to call this guy? The e to the x. We'll do h of x. Okay. What about 3x sine of x? Give me your favorite letter.
Q.
Q. Oh dear. Okay.
Nice.
All right, and then what do you want to name this guy?
V.
V? Okay. That's cruel. All right.
Hey, you got nice V's.
Oh, really?
All my V's look like U's, and then it gets really hard when you do U's.
Like, okay, you gotta, when you guys get to the point where you are doing U's and V's, do a little tail.
Yeah.
So you can tell. Anyway, this isn't relevant. Loop. Okay. So we're just gonna go through this one step at a time. So what is the predominant rule we're gonna be using here? Because we have, yeah. So let's do the derivative of this guy. Okay, what is the derivative of e to the x?
1.
EDX.
Yeah, it'll be e to the x. So then that's the derivative of the outside. So we keep this. And then we have to have the derivative of our q. So what's the derivative of q? What rule are we using for that?
Is that product?
Yeah. Okay. So what's the derivative of 3x?
3.
3 sine of x plus, okay, and the derivative of sine of x? 3x cosine x. Ooh, that c kind of melted. Okay, just remember that's a c. Okay, and then we've done the first part, and that's all times the natural log of 2x. Okay, and I'm going to write it down here because I've already run out of space. So plus, now the derivative of this guy. What's the derivative of ln of 2x? Or v? Close. 1 over 2x. And then what's the derivative of the 2x? Yeah, 2. So, yoink. Okay, cool. And then this is all multiplied by e to the 3x sine of x. Okay, let's clean this up a bit. So we have an e to the 3x sine of x on both sides. Whoa, what? It like fell out of the sky. I apologize. That should definitely be in the exponent. Do you guys ever do that? Where you just like, it just falls down? You're like, whoa. Okay, so that guy's pulled out. So now we have here, we have left 3 sine of x plus 3x cosine x ln 2x plus, holy cow, 1 over x. That was a lot. Do we have any questions? Did I do that right? Let's check. Is that the same answer I have here?
Yeah, this one's pretty gross.
It's just a lot of little pieces, so
Yeah.
which can be hard to see. So
Yeah, you gotta keep all of it straightened out. Like when you're doing the product rule here, you gotta make sure you include all your bits multiplied by the outside function there, right?
that's why I like at the beginning, I like to look at it and say, okay, what is going on? What are my what are my things here? Yeah, do you have any questions?
For the derivative of natural log, how did you get 2 over 2x?
Yeah, so ln of 2x. So it's chain rule, right? So we have the ln of x is our outside guy, and then the 2x is the inside guy. So we're going to take the derivative of the outside guy, which is going to be 1 over 2x, times the derivative of our inside guy, it's just going to be 2. I know. ln derivatives always look super janky, and then you're like, what? Where did you come from? I mess with those all the time, but don't tell anyone I said that. But yeah, cool.
Helps if you write it like that. I always write my own derivatives like that too, because if I have every term labeled out, then I know exactly where I can mess up.
Yeah,
So,
which is nice. Feeling good?
Alright, logarithmic differentiation. This is actually pretty helpful if you guys are, any business majors in here? Oh, couple? Okay, well, this is super useful in like econ and finance, but basically what you're gonna do is, I don't have an example here, so that's kind of annoying, but you're gonna take the natural log of both sides, and you're going to replace f of x with y, and then you're going to use the log property, so like that, how we split up that quotient, you're going to use that to simplify both sides of your function, or equation I mean, and then you're going to differentiate both sides, and you will have to use implicit differentiation, but it'll be like ln of y equals ln of a function of x, most likely. Okay? Then you're going to solve for dy dx or y prime. And then you have to sub y back in with the original function, right? So it'll be more clear when we have numbers to put to it, but basically you'll sub y back in, and then it'll be multiplied by the derivative of this, and then you'll get your full derivative as like a compound of the two. Yeah. Any questions before we do a primes problem? You guys remember learning this in class? Kinda, yeah? Okay, cool. So yeah, remember these log properties. The log of anything to an exponent, the exponent gets moved to be a coefficient. The log of a product is also the sum of the two logs of each variable. And the log of a quotient is the difference in the two logs. Yeah? Okay. Cool.
I think the last one is like the worst to sell it off.
Well, I can do that one if you
Oh
want.
no.
Okay.
I have yet to, yeah.
Alright, so we're gonna do this one in terms of t instead of x. I know your guys' teachers like to throw that sometimes. I know some of my students in my recitation got confused the first time. So I think it's good practice just to keep track of it. So we're gonna do it in t.
Also,
And-
try to differentiate your t's and pluses, because that can also be something that it's really weird.
Yeah. Plus sign is no tail for me. And t always has a tail, in my opinion. So we're gonna set f of t equal to y. And I'm gonna take the log of both sides here. So I have ln of y is equal to the ln of 4t plus 5 to the 2t, which also just equals, so I can move that 2t to the front. I'll draw some arrows. 2, that's a weak arrow, but 2t times ln of 4t plus 5. Okay, so then I'm going to take the derivative of this. I'm going to say the derivative dy dx of ln of y equals 1 over y times, I'll write it in y prime this time, y prime, and then the derivative of my left-hand side here, 2t times the ln of 4t plus 5 Oh my gosh, I literally made it a point. I was like, I'm gonna stay in variables of t, and I didn't.
I didn't even notice. Is that bad?
It's just ironic because I was like, this is important. You have to stay in terms of t, and then I didn't even do
It's
it.
a test. Your mom told me what not to do.
Yeah, we walk so you guys can run. Okay, this is the product rule here. So the derivative of the first is going to be 2 times ln of 4t plus 5 plus 2t times the derivative of ln of 4t is going to be 1 over 4t plus 5 times 4t. No, 4. So now if I put it all together, oh, I forgot. Okay, so to solve for, I'm going to find the board here, so I don't have to write this step out. So to solve for y prime, right? Because this is the first half of the equation. This is the second half. We're gonna have to multiply by y to the other side, right? So the y's will cancel on this side, and then we'll have this whole term multiplied by y. Yeah. So that will just give us y prime on the end. And I just don't have space to write that out, I'm sorry. Then we would get y prime equals 2 times ln of 4t plus 5 plus 8t over 4t plus 5 all times y. And then remember y equals this. So I can rewrite that by saying 2 ln of 4t plus 5 plus 8t over 4t plus 5 all being multiplied by, these technically should be brackets here. 4t plus 5 to the 2t. And that is our y prime. Any questions? Okay, cool. All right, last one.
Okay, stay with me, guys. Well, I guess if you have to go, you're good. But mentally, stay with me. Okay, so we're gonna find the derivative of this whole shebang. Maybe I exaggerated this. Maybe this wasn't as bad. Oh, we have to do. Okay, well, I don't know. Okay, so we're gonna do natural log both sides. So it's gonna be my f of x is gonna be equal to y, just FYI. So I'm gonna have ln of y equals, have a good one.
Thank you.
Good luck on your CD. Ln of x squared minus 4x plus 1 to the 3x. Okay, that looks like a t. That is not a t, that is a plus. There you go. Okay, so we're gonna use this power rule and we're gonna go boop right there. So we're gonna have our 3x out front now. Our ln of x squared minus 4x plus 1. Okay, with me so far? Okay, so now what we're going to do is we're going to take the derivative of each chunk. So dx of ln y equals, derivative of natural log is what?
Over x.
Yeah, so 1 over y. And then derivative of y is just y prime. Cool. And then we're going to have the derivative of natural log, or whoops, a little more than that. Maybe I'm not going to write this here. It's going to be non-different. We'll do it over here. Dx of 3x ln of x squared minus 4x plus 1. Okay. What rule are we going to use in order to do this? chain rule, definitely, for this guy. And then how are we going to handle having this 3x out here?
Product.
Yeah. The chain rule and the product rule. So let's do derivative of 3x first. So it'll be 3 natural log x squared minus 4x plus 1. And then it's going to be plus derivative of natural log. You guys said earlier is 1 over x. So it's going to be 1 over x squared minus 4x plus 1. And then what's the derivative of this inside goodness of happiness and joy?
2x minus 4.
2x. Dang, I thought I could turn that into something. I cannot. I have to erase it. Link. There we go. Minus 4. Perfect. Okay. And is that all? Probably not. Probably gotta put this guy back in. So it's gonna be times our 3x. Okay. So now I've taken the derivative of both sides. So now we're gonna put this back in. So we're gonna have 1 over y prime equals 3 natural log of x squared minus 4x plus 1 plus, I'm gonna put the 3x out front so we don't lose it, 2x minus 4 over x squared minus 4x plus 1. Okay, so we're going to multiply this y over, that looks like a y prime, it's not, it's just a y. So he's going to go over here, and we're going to have y prime equals y. I'm going to be sneaky. We're going to go like that. 3 natural log x squared minus 4x plus 1 plus 3x 2x minus 4. I should have probably put that 3x in there so I didn't have to write this out each time, but that's okay. It's been done.
We're gonna factor out 3. Never mind.
Leave me in the dark. Yeah, what Aiden's saying is we could also have factored out this 3, but it's done now. Okay, and then I was sneaky and I left space because we go back now and we just plug in instead of y. We put, what was my y? F of x. So it's this guy. So it was, oh, I still didn't leave enough room. I don't want to write it again. One moment. Oh, wait, shoot. Okay, one moment, please. Okay, we're going to do this backwards. So it's going to be 3x1 plus x4 minus x squared. And it was all equal to y prime. Okay. Cool. Did I do that right?
Yep.
This is where you guys disagree with me, and I'm like, no, you're wrong. Just kidding. Okay, do you guys have any questions? You feeling so good? Are we
Who
gonna
could
rock?
do this on a test?
I probably know.
This is
I don't know,
practice.
guys.
This is
This is
practice.
steps. I was looking at my notes. Okay. You guys don't have any last questions? Just a reminder: the AMLAC Bagging Math Learning Center is right there. It's awesome. They do online and in-person tutoring. It's free in the sense that you already paid for it with your tuition fees, so you should use it. They also have, if you go to that website, they have, and on YouTube, they have a YouTube channel. How cool is that? And these CBE reviews get posted there. So if you want to just listen to Aiden and I talk about this all day, you can. You could put us in your earbud and walk around campus. So that's an option that you have.
That good ASMR voice.
I don't know about that one. Okay.